So, in the last lecture, we could understand how to do the open circuit test of the transformer to find out the shunt parameter of the transformer on open circuit. But one point has to be kept in mind. We are telling that magnetizing current is very small. When magnetizing current is very small, it is difficult to measure it accurately. When current is very small, it is difficult to measure it accurately. So, what you do is, we want to conduct the whole open circuit test to that side where current is more. You know, in transformer, if it is this is the high voltage side, because number of turns are more, it is the low voltage side, number of turns are less. We all know that at the low voltage side, voltage is less, but current is high. So, open circuit test is always conducted at the low voltage side, so that we get better current, that means more current, which can be measured accurately. So, open circuit test is done on the LV side of the transformer or low voltage side of the transformer. So, now let us see how to find out the series reactance and series resistance of the transformer, that means R and X. First thing, it should be kept in mind that magnetizing current is very small. When if I load the transformer full load, that means whatever rated current it has to carry, if I give the full current to the transformer, then magnetizing current is negligibly small. So, what we do is, we load the transformer by full. How we load it? We short circuit the secondary of that. This is the secondary terminal. This secondary terminal is short circuited. If I short circuit this terminal, then the current will be such high current will be flowing that the current I, which is flowing through this shunt impedance, that will be negligibly small. So, I can omit this shunt branch completely. If I omit the shunt branch completely, now it is just a simple circuit with a voltage and the impedance of the transformer. So, this impedance can be measured very well just by voltage by current. That means, just applying Ohm's law, if I1 is the current, then Z of the transformer will be V1 by I1. I1 is the RMS value of this current. So, Z is V1 by I1. So, this can be very well measured. So, what you have to do? We will have to short circuit the secondary. If I short circuit the secondary, my requirement of voltage will be very less. Small voltage will be able to drive full load current, because we want full load current to pass through this. Full load current to pass through this secondary and primary, so that I can get the full effect. That means, when full load current will be flowing through the transformer, how the whole primary and secondary coil will behave, how much losses will be there, copper loss, that means loss which is caused by the passing of current through a resistance. This primary and secondary both are having this resistance. So, this resistance will cause the full load losses, copper losses. So, that has to be accounted for. So, what we do is, we drive by adjusting the voltage, we drive full load current through the circuit under short circuit condition. So, it is seen that if I only give 15% to 20% of rated voltage, if we give 15 to 20% of rated voltage, I can drive the full load current through this short circuited condition. So, what we do is, secondary now in place of open circuit, I do is short circuit, and to measure the current, I short circuit it through an ammeter. So, through an ammeter we short circuit this, and then same type of current measurement, watt measurement, that means power measurement, and voltage measurement. This voltage I told will be 15 to 20% of the rated voltage. This variac will be there, this variac is there. But please keep it in mind. Now, as it is short circuited, high current to be full load current will be flowing through the secondary. So that is why we conduct this short circuit test, that means all measurement part we conduct on high voltage side, where current passing will be less, because as it will be high voltage side, current will be less, and we will short circuit the low voltage side through an ammeter. So, here this side will be high voltage side and this side will be low voltage side. So, it is low voltage side. So, I will have to reduce the number of turns. So, it is a low voltage side and this will be the high voltage side. So, short circuit test, this test is called short circuit test. This test is called short circuit test. This is conducted on high voltage side, keeping the low voltage short circuited. Now, if I know, as soon as I know this resistance, this impedance, what is the value of resistance? We know this power which is getting consumed is nothing but this is current I square into R. This power which is being measured at full load current is I square into R. So, R is W by I square. That means that current, this current ammeter, from this current I will get I. This I, if W is divided, that means what is divided by R square, we will get the resistance. As soon as I get the resistance, your reactance X will be root over of Z square minus R square. So, X will be root over of Z square minus R square. So, we are getting R, we are getting X. Now, if you want to separate that R1 and R2 dash, we just measure the R1, that means resistance, by just DC voltmeter ammeter method, giving a small DC voltage in the resistance and measuring the current, we get the resistance of this. Then convert this resistance of the primary into AC resistance, and then increasing the resistance for working temperature of the transformer, that is around 75 degrees Celsius. If I get that resistance, from that resistance I can find out from R, R2 dash will be equal to that this resistance minus the resistance of the primary. So, secondary resistance referred to primary I can separate, but separation of X between primary and secondary generally is not possible by this method. So, it is conventional that if you want to separate these two leakage reactants, then it is divided equally between the primary and secondary. That means, whatever X I are getting, if I do half of this will be assigned to the primary leakage resistance, reactance, and half of this will be assigned to secondary leakage reactance. So, by this method, by these two experiment only, open circuit test and short circuit test, we can find out all the parameters of equivalent circuit of the transformer. So, one thing only I want to just clarify here. In the short circuit test, as voltage requirement is very small, 15 to 20%, so flux, working flux will be very, very less. When working flux is very, very less, our core losses, that means losses caused by the flux, also will be negligibly small. So, in the short circuit test, we ignore this magnetizing current as a whole. In open circuit test also, as current is very small, we ignore the copper losses, because current is very small. I told you 2 to 5%, that means it is 0.02 of the full load current, and actual loss is I square R, the square of that. So, 0.02 will be 0.0002. That means it is very less power compared to the full load power. So, that loss is again ignored in the open circuit test. Copper losses are ignored. We consider that all losses are getting caused by the magnetic flux as a core loss. So, open circuit test give us core loss of the transformer, and short circuit test give us the full load copper loss of the transformer. So, in the next class we will see that how we can represent these circuits, this equivalent circuit. We can further simplify the equivalent circuit, and also we can approach the transformer in a different way to find out different types of equivalent circuit, which is also having some specific application.